Alright, we're back with Chapter 29, Problem 4. I was interrupted by my iPhone storage capacity, which is quite small. I don't know whether you would know this, but I've actually hung just my iPhone on some towel hangers because, like, my laptop camera isn't good enough to resolve the whiteboard. So, anyways, I'm doing the best I can with what I have. And the last we talked, we had looked at this situation where we had a wire that was carrying current and it went to a 90-degree angle, took a left turn and went this way, and we were figuring out the B field at this point P. And what we found out was with this wire, that the B field caused by that length of wire went to 0. I definitely recommend watching the video that I did before this one, part 1, to see why that goes to 0. So what we ended up with is figuring out that the only thing that mattered was this current carrying wire, and we found that the B field at some distance P away from this perpendicular connection there is equal to mu sub naught times I divided by 4 pi x, where x is the distance that P is away from the wire. Now this is quite interesting because if you derive this formula for magnetic field for an infinitely long wire, so infinitely long on both sides, what you'll find is that the B field is equal to mu sub naught times I divided by 2 pi x, or as it is commonly written, sometimes in the equations you'll see this x is replaced with r. Not in the case of our derivation because the book said this was x, but a lot of the formulas in your book is going to say r. So interestingly enough, the B field caused by half of an infinitely long wire that's centered with P is actually exactly half of what a full infinitely long wire would cause at point P. So anyways, that's the solution, except we had labeled this X, so that's the solution for problem 4, and I'll see you next video.